At some point, almost everyone has experienced it. A bee appears out of nowhere. Not landing. Not attacking. Just hovering silently in front of your face. For a few strange seconds, it feels deliberate. As if the bee is studying you. Most people assume the bee is confused. Or curious. But scientists now know that bees can recognize patterns, remember locations, learn from experience, and in some cases, even distinguish between human faces. Which raises a strange possibility. When a bee stops and hovers in front of you like that, what exactly is it seeing? Because the bees in your yard may be paying far more attention to you than you realize. And tonight, we are going into the hidden world of how bees observe humans. Why they stop and stare. Why some people attract them more than others. What information bees carry back to the hive. And why scientists still cannot fully explain the intelligence hidden inside a single colony. Welcome back to the Bee Mind. Subscribe before you leave, because the behaviors you are about to learn are happening around you every single day, almost completely unnoticed. And by the end of this video, you may never look at a bee the same way again. Number 1. Why bees hover near humans. The moment itself is strangely unsettling. A bee approaches. It slows down. And then, it simply hangs in the air directly in front of you. Not moving randomly. Not bumping into things. Perfectly controlled. Watching. To humans, this behavior feels personal. But to the bee, something very different is happening. Bees experience the world visually in ways that are difficult for humans to fully imagine. Their eyes are made of thousands of tiny lenses called ommatidia. Each one captures a fragment of the environment. Together, they create a highly sensitive system designed to detect movement, color, patterns, and light with extraordinary precision. A bee can process visual information significantly faster than a human. Movements that appear smooth to us may seem slow to a bee. Which means that when you wave your hands suddenly, the bee sees every detail of that movement with startling clarity. And hovering is one of the ways bees analyze the environment around them. Especially objects that are unfamiliar or potentially dangerous. To a bee, you are not a person. You are movement, shape, heat, color, smell, behavior. A constantly changing object inside its environment. Researchers studying bee flight behavior have discovered that bees often pause in front of large moving objects in order to stabilize visual information. The hovering itself is not hesitation. It is analysis. The bee is collecting data. Distance. Movement. Threat level. Direction. This is one reason bees often hover in front of faces. Human faces contain enormous amounts of visual information. Contrast. Dark eyes. Moving mouths. Shifting expressions. And unlike flowers, human faces move unpredictably. To a bee, your face is one of the most visually complex things in the environment. There is another reason this behavior feels so intense to humans. Eye contact. Even though the bee is not emotionally staring at you in the way another human would, the direct alignment creates the psychological feeling of being watched. And deep in the human brain, being watched always triggers attention. This is why so many people remember these moments so clearly. A bee hovering silently in front of them. Perfectly still. Close enough to hear the wings. As if it were trying to understand something. And in some ways, it is. Number 2. bees can recognize human faces. This is the part that surprises most people. For decades, scientists assumed insects were too simple to recognize complex visual patterns like faces. But honeybees repeatedly proved otherwise. In one experiment conducted by researchers in Australia and France, bees were trained to associate certain human faces with sugar rewards. The bees learned to identify the correct faces with surprising accuracy. Not because they understood what a human face was, but because they learned the arrangement of patterns, dark shapes, light areas, distances between features. The same way humans recognize a familiar object instantly. What shocked researchers was not simply that bees could learn the faces. It was how efficiently they learned them. A honeybee's brain is smaller than a grain of rice. Yet inside that tiny nervous system exists a powerful form of visual processing. Enough to identify flowers, landmarks, hive entrances, navigation routes, and certain human patterns, including faces. This matters more than most people realize, because a bee survives through memory. A foraging bee may travel miles from the hive searching for flowers. And once it finds a productive location, it remembers. Not vaguely. Precisely. The shape of the area, the angle of the sun, nearby objects, colors, patterns. Researchers have shown that bees can remember feeding locations for days, sometimes longer. A bee may visit thousands of flowers in a single day, and still return directly to the same productive patch with astonishing accuracy. Which means the bee hovering near your garden may already recognize the area around your house, the flowers, the feeder, the paths, even repeated human activity. And bees also learn danger. A bee that experiences sudden aggressive movement or encounters predators can associate certain visual patterns with threat. The bee does not think emotionally, but it does learn. And that learning spreads through behavior inside the colony. A bee may not understand what a human is, but it can remember which humans feel dangerous and which environments feel safe. Which leads to something even stranger. Because a bee never keeps information to itself. Number 3. What bees communicate back to the hive? Most people imagine a hive as a collection of individual insects. Thousands of tiny independent creatures moving randomly inside a box or hollow tree. But that is not really how a hive functions. A hive behaves more like a single distributed intelligence. One organism made of thousands of bodies. Every bee that leaves the hive gathers information. Temperature, flower density, predators, wind conditions, moisture, distance, and when the bee returns, it reports what it found. The most famous example is the waggle dance, one of the strangest communication systems in nature. Inside the darkness of the hive, a returning forager bee performs a vibrating movement pattern that encodes direction and distance to food sources. The angle of the dance corresponds to the angle of the sun. The duration communicates distance. The intensity communicates value. And other bees decode this information almost immediately. Which means a single bee can direct thousands of others toward a target location without speaking. Without maps. Without language as humans understand it. Scientists still debate how advanced this system truly is. Because the hive constantly adapts. Collectively, no central commander exists. No bee oversees the colony. And yet somehow, thousands of individuals coordinate ventilation, defense, feeding, nursing, cleaning, construction, and navigation with remarkable precision. The hive responds to danger almost like a nervous system. If one bee detects a threat near the entrance, the colony changes behavior. Guard bees become more alert. Foragers adjust flight patterns. Defensive pheromones spread rapidly. The information moves through the hive almost like electrical signals through a brain. And all of this is happening silently, hidden inside walls, trees, roof spaces, or hives sitting quietly at the edge of a yard. Which means the bees around your home are not isolated individuals. They are connected to something much larger. A living network of shared information. A collective intelligence operating just outside human awareness. Number 4. Why some people attract more bees than others. Almost everyone knows someone who claims this. A person who always seems to attract bees, no matter where they go. Sometimes there is a real reason for it. And sometimes, several reasons at once. Bees are extremely sensitive to scent. Flowers release volatile compounds into the air, and bees evolved to detect them with incredible precision. Human perfumes, lotions, shampoos, even laundry detergents can sometimes mimic floral chemical signals. To a bee, certain humans may smell surprisingly similar to nectar sources. Color also matters. Bees are strongly attracted to bright flower-like colors, especially yellow, blue, purple, and white. Dark colors can sometimes trigger defensive caution because many bee predators are dark-colored mammals. Movement matters too. Fast aggressive movement increases bee alertness dramatically. Slow movement appears less threatening. This is one reason calm people often experience fewer stings. Carbon dioxide may also play a role. Bees can detect the carbon dioxide humans exhale. Heavy breathing, rapid movement, heat, sweat, all create biological signals bees notice immediately. But there are moments that feel stranger than simple biology. Moments where a bee repeatedly returns to the same person. Hovering, circling, following for several seconds longer than expected. Most of the time, there are explanations. Scent, movement, salt from sweat, environmental familiarity. But not every interaction feels random to the human experiencing it. And this is where psychology enters the story. Humans instinctively search for intention, especially in eye contact and repeated attention. A bee returning again and again creates the feeling of recognition, as though the bee has chosen you specifically. And while the bee may simply be responding to environmental cues, the experience itself feels deeply personal. Which is why people remember these encounters for years. The bee in the garden that would not leave. The bee that hovered silently near their face. The bee that followed them across the yard. And the truth is, the bee probably was paying attention to you. Just not in the way humans normally imagine. Number 5. What scientists still cannot fully explain. This is where the mystery deepens. Because despite decades of research, honeybees continue doing things that scientists struggle to fully understand. Navigation is one example. A bee can travel enormous distances relative to its body size, then return directly to the hive with astonishing accuracy. Even when wind conditions change, even through complex landscapes, researchers know bees use the sun as a compass. They detect polarized light invisible to humans. They memorize landmarks. And evidence suggests they may also detect Earth's magnetic field. But the full system still is not completely understood. Then there is collective decision-making. When a hive swarms, thousands of bees leave with the queen to form a new colony. Scout bees search for potential new homes. Tree cavities, wall spaces, hollow trunks. Each scout returns and advertises locations through waggle dances. The better the sight, the more intensely the scout dances. Gradually, support builds around the best option. Until eventually, thousands of bees reach a unified decision without any leader directing them. It is one of the most sophisticated examples of decentralized intelligence in the natural world. And perhaps the strangest part is this: no single bee understands the whole system. The intelligence exists collectively, emerging from thousands of tiny interactions happening simultaneously. A hive remembers, adapts, responds, solves problems, and survives. Not because any single bee is highly intelligent, but because together, they become something far more complex. Something humans are still trying to fully understand. Most of the time, the bees in your yard are not thinking about you at all. They are focused on flowers, temperature, navigation, the hive, survival. But every now and then, one stops, hovering silently in front of your face, close enough for you to hear the wings, close enough to feel watched. And now, you know that moment may be far more complicated than it appears. The bee is analyzing movement, patterns, threat, memory, environment, processing information through a brain smaller than a seed, yet still capable of behaviors scientists continue studying today. The yard around you may look quiet, ordinary, simple, but hidden inside the flowers and trees around your home, an entire world of intelligence is constantly unfolding. Mostly invisible, mostly unnoticed, until something pauses long enough for you to see it. Tell me in the comments. Have you ever had a bee stop and hover directly in front of you without leaving? And did it feel like the bee was actually watching you? I read every comment. And subscribe to the Bee Mind for more hidden behaviors happening around you every single day.